When calculating our trig ratios, we need to know all three side lengths of the triangle. So what do we do if we have 2 out of our 3 side lengths of a right triangle? This question is really similar to something we've done in a previous unit, where we were given a right triangle and we knew 2 of the lengths. So let's say we knew that this was length 3 and this leg was length 4, and we were asked, what's the third side length? Well, in this case, what we would do when we knew 2 out of the 3 side lengths of the right triangle, we would use Pythagorean theorem to find the third length. So let's recall what Pythagorean theorem is. Given a right triangle, we could label each of our sides A, B, and C, where A and B are the lengths of the 2 legs of the right triangle, and C is the length of the hypotenuse. So now what Pythagorean theorem tells us is that A squared plus B squared is equal to C squared, where we can see that that A comes from this leg of the triangle. The B comes from the other leg of the triangle at the bottom. And C is the length of the hypotenuse of the triangle. Now that we have recalled what the Pythagorean theorem is, let's try a couple examples where we use the Pythagorean theorem to help us find our trigonometric function. In this example, we want to find what sine of x is equal to, where x is the angle in the top corner of our triangle. But we're only given lengths 6 and 8, which are the lengths of the legs. Since we know that sine is equal to the opposite over the hypotenuse, then we definitely need to figure out what is the length of the hypotenuse in this example. To find that, we're able to use Pythagorean theorem because we have a right triangle and we have 2 of the other lengths of the triangle. So using Pythagorean theorem, we know that A squared plus B squared equals C squared. And our A in this case would be 8, B would be 6, and C is that unknown hypotenuse. So we can just plug in 6 and 8 and solve for C. So from here we'll get 8 squared plus 6 squared equals C squared, and which will be C squared is equal to 100. And now we can square root both sides to find that C is equal to 10. So now we have our hypotenuse length. And now that we know that, we're able to go back to the main question, what is sine of x? If sine of x is the opposite over hypotenuse, we know opposite, we have the 6, and on our hypotenuse, we have length 10. But are we finished? Not quite yet, because this fraction can be reduced. So we have to go through and reduce the fraction, and so we'll get 3 over 5 as our final ratio for the sine of x. Let's try one more example where we need to find the side of a length, of a leg. In this example, we want to find the tangent of x, where x is the angle in the bottom right-hand corner, and we know the side lengths 7 and 5, where 7 is a leg and 25 is the hypotenuse. So what is tangent of x? Tangent of x is equal to the opposite over the adjacent. So we know that the opposite to angle x is 7, But right now we don't know what our adjacent is. So we'll have to use Pythagorean theorem to solve for it. So Pythagorean theorem again is a squared plus b squared equals c squared. And in this example, our a is 7. Our b, though, the other leg is unknown, so we leave it as b squared. And then we know our hypotenuse in this example, so c is 25. So once we do all of our work, whoops, there we go, we get b is equal to 24. And so now we can fill in the side length down at the bottom and put it down as 24. And we can finish finding that main question, the tangent of x. Well, now we know the adjacent side to the x angle is 24. Can the fraction be reduced? Are we done? The fraction's as simplified as possible. So yeah, this is our final solution, is tangent of x is equal to 7 over 24. So in conclusion, what we've talked about is when we have a right triangle, we can label our sides as A, B, and C and use the Pythagorean theorem to find any missing side lengths, and then use that, all of the side lengths, to find our trigonometric function value. Good luck on the rest of the work.